Hello there, Turing podcast listener. If I could just borrow your ear a moment. My name's Jonah, a content producer here at the Turing.
And I'm Smera Jayadeva, a research assistant in data justice and global ethical futures.
Together, we present Too Long Didn't Read, a weekly podcast brought to you by the Alan Turing Institute. We read the big AI stories so you don't have to.
Each week, we'll be your trusted guides through the rapidly evolving landscape of artificial intelligence, machine learning, and data analysis.
Reading beyond the headlines to explore the history, evolution, regulation, and cultural impact of AI on our world and the people in it.
Whether you're a seasoned pro or just AI curious, we've got you covered.
Find Too Long Didn't Read wherever you get your podcasts.
Too Long Didn't Read, out now.
We are taking you behind the scenes of the National Institute for Data Science and Artificial Intelligence.
With unprecedented access to the scientists pushing boundaries and shaping our future, this show will take you to the cutting edge and beyond.
And whether you're an expert yourself or just science curious, this is the show for you.
Welcome to the Turing Podcast.
Hello everyone and welcome to another episode of the Turing Podcast. I'm Ed and I'm here with Aoife. Aoife, how are you?
Yeah, I'm great, thanks. How are you, Ed?
Not too bad, not too bad. Well, today we're speaking with Dr. Katie McDonough, who is a lecturer in Digital Humanities in the Department of History at Lancaster University and a Senior Research Fellow at the Alan Turing Institute, as well as Dr. Daniel Wilson, who is a Turing Research Fellow and a historian of science and technology. We're going to discuss with them a bit about their research at the Turing and the growing intersection between the world of data science and the humanities and arts. Katie and Daniel, welcome to the podcast.
Thank you very much. Great to be here.
Yeah, thanks.
So perhaps we can start with just asking you both a bit about your research backgrounds. How did you end up working in the field that you're working in? Katie, what can you tell us about your journey so far?
Yes. Well, we arrived at the Turing, bright-eyed about 5 years ago now, I think. So
it's about the same time as me.
Yeah. And it was really exciting to join Living with Machines. I was coming from the US. I'd been working in DH, especially working with kind of spatial digital humanities for...
Yeah, we should say DH Digital Humanities.
Excuse me, yes,
and
that's
Living
right.
with Machines, this was a big project at the Turing that you came to join.
That's right, yeah. So Living with Machines was, I guess, the biggest kind of flagship and very experimental humanities and really history, digital history project in particular. That was a collaboration between the Turing and the British Library, and we'll say more about it. But I came to be one of the history postdocs, like Daniel, after being in a few other postdocs in the digital humanities. My background is in 18th century French history. So not the sort of focus of Living with Machines, which is 19th century British history. So maybe I'll say more about whether that was traumatizing or not later. But yeah, it was very exciting to join a big collaborative project with lots of disciplines. I've been doing some smaller collaborations and really like that kind of work. So that was something that I was excited to keep doing. Yeah.
Awesome. And you started off as a historian. Do you consider yourself a data scientist now?
I do not. No. But I do still consider myself as a historian, but there's a big debate amongst people who do work in digital humanities, whether we are digital humanists, or you might say like the home discipline in which we got our PhD. And I think that that's a lively debate. And so going even one step further to calling yourself a data scientist or a software engineer is even, another kind of element to how the job landscape is changing for people.
Maybe we need to coin a new term like data humanist or something. I don't know.
Oh, yeah.
You heard it here first on the Turing podcast.
But I think that what I feel important about is I feel it's important to understand that historians can do many things, right? And just because you're a historian doesn't mean that you're not working computationally. So, yeah.
Right.
Yeah.
Yeah, Daniel, tell us a bit about your background.
Sure, yeah. So my background, I guess, is a bit more of a traditional history background. So I did a PhD in the history of science and technology, which is, a reasonably kind of niche field within history, but an important one. And as my sort of career progressed, I worked in a few different areas, including in another field some listeners may be aware of, science and technology studies, which I guess is a blend of some historical approaches to new science and technology, but also, I guess, a field that takes it often a kind of sociological or kind of almost ethnographic approach to what's happening in the sciences and in technology. So I guess throughout my career, I've had this interest in what happens when new technologies first arrive on the scene, how people use them, what it's like to interact with them, and to live alongside them. So I guess that was my qualification, if you like, to work on the Living with Machines project, which, was interested very much in what it was like in the 19th century, when the Industrial Revolution began to sort of have its long effects and consequences on people's lives. For me, I've also had a parallel interest in how this question continues today in the 21st century, which I guess made it especially interesting to be somewhere like the Turing, which, is at this cutting edge of introducing new methods, new approaches to, a whole range of fields, mainly in the natural sciences, but also now as well in the humanities and with history. So I guess I had this kind of double interest, both in the historical question, which was the topic of the Living with Machines project, but I guess there's a kind of meta question about what it's like to work with computers and machines in a field like history, which I guess is still a kind of minority way of doing history. And, as Katie was saying, it's an open question how that will develop over time. Will computers become just a mainstream part of how historians work? Or will it be a sort of specialism? We don't know yet. It's a bit...
It's really interesting question, actually. So Aoife, you'll know a bit about this. Like me, your background as a biologist. And how do you think, it's changed in the last 10 to 15 years, like how much biologists know about computing and programming?
That's a really interesting question. I was about to ask our guests something similar.
Exactly. Well, that's what I'm thinking. I feel like maybe the arts and humanities, history in particular, might be like where biology was, 15 years ago or something.
Yeah, I'm coming at it from a very biased point of view because I've always been in STEM. So whenever I hear about arts and humanities, that to me is something I've never really heard talked about.
Yeah.
So I'd much rather hear from their point of view of what it's like coming into such a radically different field like computer science.
Yeah, my question is kind of like, so when I first studied like undergraduate biology, I never thought I'd end up being a programmer. Whereas I think now, and maybe I'm showing a little bit of my age a bit. I think now if you did an undergraduate biology degree, you'd sort of know that you'd be doing a bit of that.
Oh yeah, you'd have compulsory modules in programming and things like
that. But I'm guessing for history undergrad, you're probably not going to be doing that at this point in time.
No, although it's interesting. To think whether this is a sort of trajectory that's going to change, or whether it's something that's sort of stable, and maybe there is it's a debate around that. Within the discipline of history, there's always been a kind of strand of that which has been quite quantitative. Okay, so people were interested in economic questions for which you need a lot of detailed statistics. You might be working with the census, so there would be statistical approaches to those questions which used that data as a source. And that's been a strand going back 40, 50, 60 years in history. In the 1960s, historians began using computers to try to work with, big data sets, I guess we'd call them now.
Right.
And that was known as cliometrics, clio being
the muse of history.
And metrics. So there was a kind of, I guess, a strain within the historical discipline that did that kind of work. And that sort of went out of fashion in the 70s and the 80s, or even later. And, there's been different, I guess, trends over the last 40, 50 years. One thing I think we can say about the present situation, and this might apply to Living with Machines to some extent, is that the reach of computational methods is now sort of going beyond just kind of data sets, which are, I guess, what you might call hard data or statistics, which are, demographic, for example, but also include things like more qualitative material to work with.
Right.
So text sources, which, you can say something quantitative about. Now you can say some quite sophisticated things about using computational methods. So, for example, you might think about a language model as a way of exploring, books and newspapers from the past, in ways that are, I guess, getting towards a more kind of qualitative way of thinking and working. which is more common to how most historians work. They're reading texts and trying to interpret them in ways that aren't necessarily quantitative, but now we can actually use some of these tools to say stuff that is quantitative, at its base. So that's,
I would just add to that. I think that, Daniel highlighted the kind of rise and fall of cliometrics. And I think also people who are historically minded, but also really believed in that those methodologies around statistical interpretation of the past really kind of gravitated towards economics departments rather than history departments. And so you do see like kind of economic historians, especially in the US, will be in economics departments.
Right.
And here, I'm not quite sure how that divide works, but that was a kind of disciplinary, sort of parting of ways, mid-century that has continued to impact and kind of allow historians to behave and have opinions about the way that they think they're interacting with computers, or which really there's a kind of elision between computing and quantitative methods. And Daniel's just made this really nice point about really moving beyond that assumption, but that's really deeply ingrained. And I think this point about what do undergraduates learn? Right. What's the toolkit that a historian has for thinking about what will count as data or, relevant sources of, understanding the past. And I think that while we're seeing a real explosion of master's level education that can be quite computational, at the undergraduate level, that is not part of the curriculum. And that's true internationally. So I think that I imagine the potential for change is there, but it's very hard because there's very, kind of deep pathways that help people understand what they want to study and what they're going to learn at university. And if someone is interested in thinking, about data at scale, it's not a natural thing for them to think, oh, I'm going to major or I'm going to get a degree in history and apply that kind of thinking to historical information. So you do get a lot of say someone who did an undergraduate degree in computer science or linguistics, then moving into perhaps doing a master's or a PhD in a more digital humanities area. But
then you don't have the background in history.
Right. And so there is a give and take there. And I think that, everyone has different pathways. And I think that's one of the reasons why collaborative projects are more and more common, right? Because we really do have people who have already quite hybrid training. But we still need to bring together slightly different versions of those hybrid, backgrounds to do work like this. So I've found that just the lack of a traditional career pathway for people who want to be part of these projects is really fascinating. And I don't know, maybe that I think it's a hopeful thing for people doing PhDs, right? To show that there are ways that are right. We're kind of evolving out of traditional assumptions about what people if you do one discipline, you've got to stay in that discipline and you can't shift around or you can't change the nature of that discipline. Anyways, I think that's really exciting, and Living with Machines has been a demonstration of the power of that kind of model, and welcoming people with different backgrounds.
But I think what's interesting is you're saying it's partly about sort of interest, in the sense that if you go to study history, you don't necessarily go because you're interested in computer science or statistics, and vice versa.
And
so
indeed, people can be quite hostile to doing something like that, actually.
But what I was actually going to say is, the point that Daniel was just making is it might be something to do with the tools as well, because if you're specifically going into economic history or you're doing stuff with demographics, then the tools have existed for a while. Maybe it's just, Excel, or maybe it's, doing data analysis with some stats packages. There's the basic programming languages we're familiar with, but the kind of software you might want to use for qualitative research might be much more recent innovations. So maybe that's as well as the obvious like differences in interest. Maybe that's the reason why it's happening now rather than 20 years ago or something.
Yeah, and I think that's particularly the case if you look at some of the work we've been doing and others, are doing using different types of source material. So I've mentioned texts, which newspapers and books would be a typical thing. But one of the things we set out to do on Living with Machines is try and work with maps as well, and historical maps. And I guess once you try to imagine what that would look like, you have to try and come up with a whole new different toolkit. And in our case, we had to sort of create one from scratch.
Well, that's a nice segue. So we can ask you a little bit about the tool that you did make. So I hear it may have won a prize, in fact. MapReader is its name. What can you tell us about it?
Yep. So we're really honored that the American Historical Association, which gives out annual prizes for important books and major outputs in the field of history, and not just to Americans, but internationally. They have a digital history, sort of creativity in digital history prize, which is co-sponsored by the George Mason Center for History and New Media. And so MapReader won the prize, and we're just thrilled because I think it really speaks to, something that just bubbling up. We really came to Living with Machines with a desire to work differently with sources that have been relatively recently digitized or just scanned, right? Not digitized at any other higher level. And to do that, we had to just start really from scratch, because one might have said, well, there's a long tradition of working with spatial data in GIS software. There's a whole field, GIS science, right? But we wanted to really think qualitatively about how to understand the content of maps at scale. And that was a kind of problem that people hadn't really tried to address yet, to the extent that it's really very difficult for a historian, or really anyone, to consider what kind of question you might ask, or what you would do with the information that you get if you try to find patterns of the presence of some kind of visual feature, for example, on 15,000 maps. What do you do with that, right? And so the kind of novel nature of that problem was really exciting to us. And Living with Machines, because of its length and because of the depth of multidisciplinary expertise, really allowed us to pursue that in a way that would never have been possible if we were, one person in a department putting in a grant proposal to do something a bit wild and crazy like this.
So there wasn't an actual question behind MapReader. It was more of, let's get this together so we can then start asking questions about what we find.
I mean, if I can, say a little bit about that. I guess one of the unusual things about Living with Machines is that the project sort of came together, as you say, without clear research questions, but more like a set of research interests and themes. So if we didn't already say, the main sort of aim of the project was try to think about the impact of industrialization on people's lives and the lived experience of being in the 19th century in Britain. So one of the things we started to do is just, in terms of thinking, what must that feel like, try to get at the lived experience, which is the thing that historians, are often interested in. We try to think what kind of spatial characteristics that might have. So what would it be like to live in a certain place? What would it be to live in proximity to certain things? And because our theme was industrialization, we were interested in the kind of things that would be relatively new in the landscape. So, factories was a thing we discussed. Steam engines are the kind of things people think about. So we wanted to try and think about spatial relationships that you could try to understand at scale, and try to get a kind of fresh handle on that. And maps became a source type that we began to work with and think about. And through that sort of discussion, we began to think about these questions to do with proximity, which I guess is where history becomes a little bit more geographical in some sense. And what could we say about these relationships in space on the ground, if you like, between where people live and new things that they might be encountering for the first time. So, for example, a steam engine pulling a railway train. So that was the kind of discussion that led to us thinking about a tool for working with maps, and a particular set of research questions then sort of emerged out of that, which we, I guess, translated into software engineering problems, which we then tackled with our colleagues who were, already kind of skilled, or if not skilled, very interested in things like computer vision and other kind of methods that we then sort of like depended on very heavily.
And maybe was the thing that came before the idea for the software, the map data itself that you were going to be using. So I think the British Library had basically all of these maps that could be used.
It's worth saying that the British Library provided a huge amount of the data for Living with Machines, mostly newspapers. However, it's important to highlight that the British Library has the largest physical collection, so the actual paper maps of the maps that we were using, which are British Ordnance Survey maps. So, everyone who goes out for their walk, their little ramble on Sunday morning, and you've got your little map. It's the orange, the orange cover.
Still buy them in shops,
right?
I think.
Those are the maps that we were using, but we were using the earliest editions of those
from the 19th century.
The 19th century and the early 20th century. Now, yes, so the BL, the British Library, has those physical historical maps in the collection. For the most part, the British Library hasn't been able to scan those maps. However, the National Library of Scotland has gone through massive campaigns to scan their Ordnance Survey collections, which in fact were they received those from the Ordnance Survey archive. So it's a kind of interesting history of maps. But I can't resist. This is where we go as historians. But so we were really lucky to be able to work with the NLS to work with their digital collections. Everyone should go check out the kind of NLS map viewer websites. Are really amazing sort of portals for viewing these collections. And maybe just to kind of take this a little bit further, is one of the kind of methodological sort of motivators was, well, we've got all of these maps that have now been digitized. We can browse them, right? We can kind of fly over them like birds, but we can't actually analyze their content in this way. There hasn't been a mechanism for doing that, and that was a very, very exciting challenge because institutions around the world are spending a lot of money scanning these materials and making them kind of pretty pictures on the internet.
Right.
We can do more with that, and there's a whole movement, or
they're just images as opposed to sort of data objects you might be able to query in some way as their contents.
And the NLS has gone quite far in terms of geo-referencing their maps, right? So what that means, right, is if you have a scan, instead of it just being, an image, effectively, if you geo-reference the image, then you're pinning that image down to its location on the Earth. So the metadata, right, the kind of additional information that we store about the image, doesn't just tell us the number of pixels and kind of potential pixel coordinates of content in a map. It also we can express those pixel coordinates as geographical coordinates, as latitude and longitude, and that makes that map, that image, it's one step closer to it being a really exciting and easy to use object for research. I was just going to say that there's a real kind of push to think critically about how we're using collections as data. So there's a lot of people writing about this sort of coming out of the library and archive and museum world. And as researchers, we're really excited to collaborate closely with librarians, curators, right, archivists, who are thinking really deeply about what it means to prepare collections in a way that can be useful for lots of different audiences, right? It's incredibly important for those maps to be images that people can see. The general public has all kinds of uses for those. Primary, secondary schools have all kinds of ways that they might want to interact with maps. Researchers are another audience. And I think what's really important is that all of these audiences are being listened to think about, right, what does it mean for collections to be exciting for all of these audiences? And it's only now, with the emergence of kind of recent computer vision technologies, that the kind of possibilities for working with these collections for research has really exploded. So now we're, people are kind of banging down the doors of libraries and archives asking for this content. And libraries, it's not cheap, right? To kind of transform huge data sets into what, we might call research-ready data. So that the NLS had really done a lot of that work already. We were incredibly lucky to work with them on that. And this work wouldn't have been possible without it.
So once you had that data then, and it's maps, I guess, through time and georeferenced, and then you started working on the MapReader software, what were the kinds of research questions, and you mentioned computer vision a bit as well, what were the kind of research questions that the software enabled you to answer with that data, and what was sort of the interesting outcomes of having answered those questions?
Yes, I mean, as Katie was saying, these maps existed already as digital objects, and historians have used them, but the way they use them is they might take one map and use that as a piece of evidence to say, here's this one town, let's say in Yorkshire, where someone lived, and we know their name and their address, and we can see what their street was next to, and it was next to a railway line, and we can say something about that, and you might augment that with some information from their memoir or their autobiography, and they can tell you something about it. But we wanted to find out really at scale what kind of patterns you might be able to pick up across the whole country about these kinds of relationships. So, maps are a visual source, obviously. And, unlike text, when you digitize it, with visual material, there's no way to just search it. You can't type into a search box, show me the railway on this map. Okay. So that's where computer vision comes in. And, together with some colleagues of ours, Khazra Hosseini, Daniel van Strien, who we should mention, who were sort of instrumental in coming up with this method, we borrowed some techniques more familiar from the world of medical imaging, where you take a photograph, let's say, and you slice it up into smaller pieces, patches, we call them. So we patchify these maps into tiny little squares, and then using a kind of, I guess, fairly by now quite well-known method in machine learning, we would annotate these images, and we'd be looking for certain phenomena in the image. And we began this in quite a simple way, just to see if it would work. So we were interested in railways because we thought this is a question that is quite well suited to this approach, including the fact that it's a kind of nationwide phenomenon. So having access to this whole nationwide collection, we thought this would be an interesting thing to pursue. We annotated at great length manually. I should say Katie did a sort of heroic amount of manual annotating. We all did, but I think Katie won the prize for doing by far the most. So that was where we began, I guess. And then because this material has been georeferenced, as Katie was saying, you're able to then cross-refer this data about where this phenomenon is with other data sets that you might have. And those might include things like, for example, the census. So who lives near these railways? And then we began to ask, are there patterns we can detect about who's living where, at what distance from a railway? And then you can build on that with other data sets that are also relevant. For example, where are the stations in the railway network? So a kind of whole set of materials over time came together in this research, which allowed us to ask some quite novel and unusual historical questions about what's happening spatially on the ground, if you like, in the past, and also at scale across the whole country. So you're not just looking at a case study of, Ashton-under-Lyne or somewhere famous up north for its sort of industrial history, but you can actually compare across the whole of the country from Devon and Dorset to Lancashire, Yorkshire, and everywhere. So that was kind of a really exciting thing that we've been able to do now. And yeah, we're working on various papers that will sort of push this research further.
I just wanted to kind of give a sense of what the scale is, right? So for the sort of 15,000 or so maps in one particular series and one edition of OS maps that we were looking at, when we talk about patchifying those into these little cells, so we go from 15,000 sheets to 30.5 million patches. So if, as Daniel was saying, if you're thinking about, oh, well, we don't need machines to do this, it'll be better if we just do it by hand. Imagine trying to do that, right? So one of the things that we thought long and hard about is, right, like what's the kind of cost benefit here? Because when you do use a method like this, a machine learning method, we're introducing a new source of potential error, right? Not all the results are going to be accurate, right? In the sense that it's not predicting the label that we're searching for.
So one can imagine if you came to the project at the start and you got all of these maps with basically a certain kind of line that corresponds to a railway, and you're trying to say these are railways and these are not, but your machine learning classifier says, oh, well, these roads are railways. Clearly, they're also lines. So how tricky was it to like make it get that right?
Well, this is where having a really kind of deep understanding of the maps themselves is essential. And so we spent, like Daniel said, actually, there's this really kind of wonderful interplay between designing a method, right? Designing the software and spending time with the maps as sources, right, that you're interrogating. And in that process, we really came to have a much deeper understanding of what are the consistent and sort of unique visual signals on these maps that we can ask questions about, on a nationwide scale. And so, there was one, at first we were working with the 25-inch maps, and we wanted to identify, so we were identifying railways, but we were also interested in identifying whether there was a building in a patch or not. So for the buildings on the 25-inch maps, they're represented with this kind of hatching sort of texture pattern on them. Now, that pattern is exactly what all the coastline, sort of rocky areas also look like. And so, when we were just starting out with fine-tuning some models to find buildings on the 25-inch maps, we were getting all kinds of false positives, right? So things that are being predicted to be a building by the machine, which were not, in fact, buildings. And so actually that prompted us to switch to a different scale of the OS maps so that we could avoid that problem.
Right.
So the buildings on the 6-inch maps are just a footprint with a blank sort of center. This matters a lot. You have to really think about the relationship between the thing that you want to find, which is meaningful to a question that you're asking, and kind of the field, right, that you're working in, but also something that has, consistency and some uniqueness on the maps. It's probably worth saying that the kind of maps that we were working with it's really important to take into consideration. So one of the things that we're working on now is we're really excited to help people beyond living with machines work with MapReader. But you can't just throw anything at it. So Ordnance Survey maps, right? They have this national coverage. We call it, and there are multiple scales and multiple editions. And this is what's called in kind of the cartographic world series mapping. So this very large scale series mapping initiatives lend themselves really well to MapReader. And lots of different countries have this kind of mapping.
What do you mean by series mapping? Sorry.
It means that, right, so there are individual sheets, but those sheets fit together in a continuous series of representing the
time.
A larger the land.
Oh, I see.
They may also be time series, but the first is that it's a series of sheets that correspond to kind of continuous space in a country often.
And this just is caused because the limitations of paper, because these maps were made to be printed, and given to people to hold in their hands.
These are still historical maps.
So these are paper sheets. Paper sheets would be in a series so that you could make them manageable, and also sell them one by one and so on. So,
or they would, you would buy a volume for one county. So older OS maps are often, you might hear them referred to as county series, and it's because of that. Yeah. So these are maps where all of these 15,000 maps, right, look pretty much the same. They're not exactly the same, but they look pretty much the same. If you were to say, oh, well, great, I've got a bunch of maps from all different centuries and all different countries, and I want to find roads on those maps. The lack of a kind of consistent visual signal for that feature on the map is going to immediately cause you problems. Not necessarily, right, because roads are going to look that different, but roads are going to be set against different background colors, different textures. They might indeed have different thicknesses because the maps are different scales. They're going to be surrounded by other information, right? So all this kind of information that impacts the image that you're looking at will come into place. So MapReader won't necessarily work, at its best for that kind of collection, for that kind of corpus, but it will work really well for maps that are, have the kinds of similarities that we were talking about.
Is it possible to do some work to or is it just not feasible to convert one style of map to another style of map? So say, in the 19th century, the French did their maps slightly differently from the British, but, you could just find a way to, I don't know. It feels too manual, I guess, to ever really translate from one to the other.
You could have a generative
neural
network.
That's what I'm thinking.
Style transfer.
Yeah. Exactly, so there's people working on this, but I think you would want to ask yourself why you're doing that. Because as soon as you do the style transfer, right, you're introducing all kinds of new information too, right? And you don't know also if, what's being transferred and what's not correct. Being transferred and what's right. Yeah. So style transfer is, there's some lovely work that's been done by Zakun Lee and some folks at the University of Minnesota on using generative methods to create synthetic training data, right? So it's say you have a corpus of 2,000 maps. Now, it's a corpus that might be large enough that you'd want to use a model to predict something. You still don't want to annotate it by hand, but it's small enough that you might not, have enough to create a substantial enough training data set and, test data set. So the idea there is, just create synthetic training data and you kind of sidestep this problem. I think we have a long way to go to understand the quality of the results in relation to potentially kind of contrasting that with human annotations. But there's a real use case for that, and it's really exciting work. So yeah,
maybe another question I could ask is, so at the moment we're quite familiar with digital maps, whether it's Google Maps or OpenStreetMaps or so on, and obviously when you look at those maps, they do have representations of all the things you would expect: buildings, roads, train lines, and so on. So is it ever going to be feasible to translate some of these historical maps into like a very familiar format that's associated with a particular software like Google Maps? So you could say, oh, let's dial the time slider back in time? Or is it just not? Is this just never going to be feasible?
I think it depends why you want to do that. I think that'd be the main question, and I think that's something that, I guess what we are in terms of something like the Turing is we would be called the domain experts. Mm-hmm. Okay, so it's just worth thinking, like, in order to decide whether something's interesting to do, you probably need to just make sure that you have an understanding of where this data came from in the first place, so that you can make these kind of, I guess, like, informed decisions about what things might carry across and what things might not. And that's always going to be informed by the question. So, like, why do you want to do that? I guess the thing that you just mentioned there, Ed, is something that you can actually do in a way on the National Library of Scotland's map viewer. So you can overlay different maps from different time periods because they're georeferenced. You can sort of slide. This is hard to do on a podcast. It's very visual, but you can slide your mouse back and forward.
Okay, yeah, that's
you can
cool,
compare different map layers from within their collection, and that's a really fun and lovely tool to play around with. And you can find your house as it was in 1850 and things like that. But the visual language of the map is really, in a way, irreducibly different.
Right.
I think.
Yeah, because I'm imagining doing the slider over time to see like cities growing and stuff. But I guess what you're saying is like you can do that and it will be georeferenced, but the style will still be sort of changing as you go along because it's just whoever's drawn the maps.
It's also worth pointing out that, of course, a lot of the data here in the UK, that if you're looking at Google Maps in the UK, a lot of the data provided for Google or Bing or whatever you're looking at is actually coming from the Ordnance Survey. And the sort of Ordnance Survey master map, which is the data product that they use for mapping today, has been continually updated since these maps from the 19th century that we've been working on, right? So in some senses, you are actually still looking at information that has just been constantly resurveyed, at first when it was paper maps, re-engraved and reprinted. And that was all digitized by hand for the first version, of the master map. And now we're really seeing just successive generations of that data, represented with new, styles. But the other thing is maybe handy to point out is, about OpenStreetMap. There's also a historical OpenStreetMap, which documents. So OpenStreetMap is, and as I rightly should be, very dedicated to only representing what's actually on the ground today, right? And that serves a lot of important purposes. Historical OSM, which is a super cool project, is addressing that need of like trying to document what was on the ground in the past. Yeah.
Cool. So I guess a follow-up question to all of this. You develop tools like MapReader and other sort of software and data tools for the other digital humanities projects at the Turing. And thinking about going into the future, like how these tools get used, how they're maintained. What can you say about some of the challenges around this, and what work might we be doing at the Turing to think about that kind of thing?
So on the heels of the end of Living with Machines this summer, and I realize we haven't said this, but our courageous leader on Living with Machines was Ruth Honert. She was the PI, so Ruth and a number of other people have kind of really thought about what is important about kind of securing or thinking about the legacy of what we did on Living with Machines. So there's a new project which is based here at the Turing, building sustainable communities for software and data in the arts and humanities. It's so new that we're still trying to remember the whole name of the project. And so Daniel and I are and many others are involved in that project, which is really about, as the title says, building communities, in particular for historians, for software engineers, and for our colleagues who are professionals in libraries and archives, to learn to use these tools to really build a kind of communities of reuse around the tools and the data that they require for input and that they create as output. And we're so excited to have an opportunity to keep working on MapReader and T-Res, which is a toponym resolution pipeline that's freshly released, created by our colleagues Mariona Cole-Ardonui and Federico Nani with help from many others. So yeah, there's a number of things that are going to be still work in progress. We're going to be doing workshops. So stay tuned. Daniel, do you want to say anything?
Yeah, I mean, I'll just add one thing to that, which is that I guess there is a kind of relatively high bar of entry to using some of these tools. And that's one of the big challenges. There are tools for different audiences where you can just go in your web browser and look at a map. But for us, it was never a question of building that sort of tool, a front end or a website, because these things are notoriously difficult and expensive to maintain. And, we were a project, so our funding really ended and there was no prospect of ongoing resources to try and maintain that kind of tool. So that's why the word sustainable is quite important to think about and think what that means. So the communities that we're, I guess, trying to build up would be people who are researchers who have an interest in, let's say, data science methods, but will need some help in getting up to speed with the exact nature of the tool itself. In this case, the tool requires a little bit of Python. You can access it in the notebook, a Jupyter notebook. So if you're willing to take a few steps, perhaps out of your comfort zone as a historian or a geographer, the kind of work we're doing revolves around workshops where you can come and learn how to use the tool. You can maybe bring your own maps if you have some that you want to work with and try the tool out on those. So it's very much a kind of spirit of, it's not always the kind of the best word, but hacking or kind of working together and trying to take the tool and seeing how it works with different source material and, themselves. Yeah.
Nice. Well, before we finish off, is there anything else that either of you would like to say about your research, where the future of this kind of work is headed?
I think we're in kind of a golden age of what's now, kind of called document processing in outside of the world of humanities. But just the real explosion of the quality of sort of inferring different kinds of content information from very complex, including historical documents, into machine readable data is right. Like we're really kind of hitting a stride there. And I think that a lot of historians, and especially students, right, that are seeing, playing around with AI tools, it's really, really exciting to see that we can translate, very complicated, even handwritten text documents into, an XML file. So that's just, it's almost a bit overwhelming. And the opportunities there are things that, we've tried to kind of seize on, but we're really excited. I think there is an importance of like teaching people about, okay, we're going to do that, but what do we still need to learn about how that original document was created, or the people who wrote it, or why it looked the way it did? So I think that we have, our work cut out for us, but it's a very exciting time to be working with historical documents. And it's been an honor to be a part of Living with Machines.
Yeah, no, I agree with that very strongly. And also just add that for me in particular, the exciting thing is about converging different source types and different types of information to create sort of like genuinely new insights that you wouldn't have been able to find otherwise. I mean, that's the hope anyway. And a lot of our work has been about this kind of convergence. So bringing together spatial information with material from texts and other sources to, new combinations.
I guess that's what it all comes down to is, you're finding ways to make research in history not sort of manual, just scrolling through books, but having resources where all of that information, whether it's, written or maps or whatever, can be, queried in some kind of standard way, or at least in a way where you can get information out of lots of data rather than just one source, I suppose.
Yeah, and I think people will always read books. I definitely hope they will. But
we still like books.
But I think there are so many opportunities now with I guess, like Katie says, the transformation of different sources to machine readable form. It just opens whole new horizons.
I don't like books. I can't do Control F on a book, so I can't find what I'm looking for. It's too difficult.
We can help you with that.
Good, awesome. It's good to hear. All right, Katie and Daniel, thanks very much for coming on the podcast.
Thank you.
Thank you very much.
Thanks for listening to this week's episode. The show is hosted by me, B. Costa Gomez, Ed Calstry, Joe Dungate, Christina Last, and Anika York, and the episodes are produced by Luca Lane. Music for this podcast is produced by Jam and Sun. You can listen and follow via the link in the description or by searching Jam and Sun on Instagram.